everyone have a good lunch? Perfect. Cool. Guess we're ready then. So today we're going to talk about low-code for developers. How many of you have heard of low-code? How many of you have used low-code? How many of you have built low-code? Awesome. So at least one person here or two people here have sort of interacted with this, and I'm sort of here to sort of get you interested in what this is and why this is important. Okay? So give me like 20 minutes, see if this makes sense, and the next 40 minutes we'll sort of try to make this interactive, and we'll get questions. We'll try to make this, make sure we're all on the same page. We all agree upon what this is, why it's good, why it's bad, how we can as a developer community move forward adopting new ideas. So that's sort of the plan. I'll preface this by saying we'll talk about building a low-code product that developers don't throw out in a week. So that's going to be like the common theme throughout this presentation. Quick introduction, I'm Ekaansh. I'm a developer advocate at Agora. I speak JavaScript, and I also maintain like the UI kits for Agora, which are like low-code tools. I have been building these for more than 2 years now, got some experiences on what developers hate the most and how we can sort of work around those problems. I'm also into I make bad art and music. That's why I picked like software engineering, because it's more objective and you suck less when you can measure performance and things like that. You can follow me on Twitter and GitHub to see the things that I'm working on. So let's start with the definition of what's low-code, right? And I like to define it as abstractions to simplify developer experience, which lets you focus on things that matter. And that's a mouthful, but essentially we're going to talk about building abstractions, and let's look at this with an example, right? You have your CPU, which sort of processes all instructions and all sort of program runs on the CPU, right? On top of this, we built assembly because writing binary for the CPU was really hard, so we built this abstraction to make interacting with your CPU easier, right? How many of you write assembly? None of you? Awesome. That's because we built high-level languages that sit on top of assembly, which is an abstraction which gets converted to assembly, which gets converted to bytecode, which gets executed on the CPU. So your lower layer is your CPU, which has sort of been there for like the last 50 years, but we've built abstractions which are easier to sort of interact with this underlying layer. And this is sort of like a layered system which we talked about in the quiz. The next logical step on top of this, in my opinion, is libraries. Let's take the example of Node.js, and before we start going into this, can I see a show of hands? How many of you are front-end developers? Or work with front-end, like understand front-end? Cool. Back-end systems? Cool. Tough crowd. So libraries, usually let's take the example of Node.js, which is like a JavaScript runtime. Usually when you're building, let's say, a server in Node.js, you're not directly writing Node.js APIs. You're using something like Express, which is a library built on top of this framework. And what this allows you to do is focus on things that matter. You take your request, you process it and return a response. You're not working with, like, let's say, the TCP protocol. You're not sitting there implementing, this is my packet, this is how I put this package together to get my request. You're not directly interacting with these things, but you're still sort of able to convey ideas and process information for your end customer or your end needs while working within the bounds of this abstraction. Does that make sense? Does everyone agree? Any questions, disagreement? Cool. Hot take. The next logical step on top of libraries, in my opinion, is low-code and no-code. And this is not just like a traditional step up, so I've made like diagonal arrows. These sort of coexist, and these are sort of murky, and like there's a fog of war between these. And that's sort of what we're going to clear up and sort of talk about and sort of, figure out if we all agree that this is the next progression. So, does anyone have doubts on what low-code is? All good? Yeah?
What is low-code?
So, for now, all I want you to understand is it's a next step forward. It's an abstraction built on top of libraries, which enable you to focus on writing applications in more concise way, right? You're not writing like, sorry?
That's what the C language is also about. It's also low.
So let's take this example, right? Like C language, if you're expressing a web server, it would at least be like a 500, 1000, 2000 line program. Writing this in Express would be 20, 30 lines. Writing this in no code might just be like one line of code. So we're building abstractions to make things more concise. That's sort of what it's marketed as, and we're going to discuss why this becomes a problem. and why it's it's not directly like on top, and like why we're not writing low code right now. Before we get into the problems, let's sort of get you one step closer into why all of this matters, right? And before jumping into it, taking the example of what I was trying to describe, if you're building like a video call application on web, you're probably using something like WebRTC, which is your sort of protocol which takes data buffers and converts them to send them across the network. Making this on your own would be like thousands of lines of code easily. Like there's no other way around this. You would have to implement so many things. But what we're seeing coming from a video SDK company, what we're doing is we're abstracting these all into like simple components. Like you plug this component into your website and it takes care of everything, right? You have this video call component, you can pass in some styling, you can pass in config, you can pass in callbacks, and this takes care of all of the things, all of the life cycle of your application. So you're making the description of this video call more concise. You're taking developers' opinions and sort of pre-computing these beforehand. Sort of saying that you have a video call, you probably want a mute icon. You have a video call, you probably want to see the other people on the call. You have a video call, you probably want to have a button which ends the call. Like these decisions I can sort of pre-compute before giving access to the developer. And that's sort of making things more concise so you can focus on the rest of the application. Like what happens when a user joins, things like that. So does that answer your question?
It's been what we have been doing for since I think 10 million. It's all gone at a higher level or more complicated.
That's exactly it. It's nothing new. It's all we've been doing.
We were talking about a component-based architecture, which what else? We are actually seem to be giving fancier names to things that we have all been doing.
That's exactly it. You've hit the nail on the head, right? This is nothing new. It's just
fourth generation languages and all that stuff was there.
But this is sort of the next, and I'll sort of describe how this differentiates a little bit from your 4GLs, because even there you have to describe a lot of schema, you have to describe a lot of things, and it's a little bit difficult, but we've sort of talked about the same idea. This is the next step forward. This is an abstraction on things that we've all been doing. It's sort of a way of writing programs where you're sort of being more opinionated when you're writing code. Cool. Lots of companies are building things on low code. These are some popular brands or companies that have made strides in low code. Like Shopify, you take a component, plug it in, you have a storefront. Webflow, you describe some styling and you have a website running. Airtable, Zapier, and on top of this you have WordPress, which is king of the web, sitting right at the top. So why low code? Why am I here to talk about this? We've established that this is a common pattern. We've been doing this for a while, but why now, right? So there's a Gartner report which says that by 2024, 65% of all application development will start with some sort of a low-code activity or will be based on low-code. This seems like a inflated number and like some marketing gimmick, but there's at least some truth to it, right?
Gartner also has the famous hype cycle, right?
100%. I'm not saying this is exactly.
So this seems to be just on the cusp of the hype cycle at the moment.
Yeah, but
I didn't make this report, but I'm sort of trying to say that when a bigger organization puts this into words, it's easier to buy. Like, you wouldn't believe me saying this here, but when Gartner says it, there's some credibility associated with it, right? And if you want to listen to me, WordPress is still king, according to me and everyone else on Twitter. And 43.2% of all websites on the internet are based on WordPress. That's an insanely massive number, right? And I'm just going to quickly connect to the Wi-Fi because I have some tweets that I want to show you. Let's make sure this works. Let's try that instead. Sorry about that, give me 1 second. Let's refresh. I have a couple slides with tweets which I sort of want to reference. Let's give this one more try, and if it doesn't work, we'll proceed without. without that. Let's see if it's a problem with the slide or internet. It seems to be connected. Is everyone else able to access the internet?
Are you sure you entered the right password?
I hope so. Okay, we have internet. Perfect. Nothing like a talk goes without having like some minor like technical hiccup. That's why we are here, right? Fixing things, making things better.
Murphy's law.
Sorry?
Murphy's law.
Exactly. Like anything that can go wrong will go wrong. So speaking of WordPress, almost half the internet still runs in WordPress. How many of you hate PHP? Quite common, right? Like everyone hates PHP, and we're sort of coming back to the circle of like writing your front end and your back end in the same file, which PHP popularized like 15 years ago. So circle of life. But the idea that I want to take away here is that PHP isn't going down. Like actually every year WordPress gains 3 to 4% of market share. That's one Shopify every year. So even though we all collectively hate WordPress and we think that's not like the best way to move forward, there's React, there's Next, there's all these cool like things like Remix. We're still shipping WordPress by a lot. So when you sort of Google like why low-code is the future, the first result you actually get is why low-code is bad. And I agree, like I am here to talk about low-code and I'm excited about low-code, but the low-code the way it exists right now is not ideal. And a quick example of the overall arching theme is that you have this thing which does there's some low-code tool which does some magic, and let's disconnect that call. The problem comes where, what if I want to do some other magic which isn't supported by this low-code tool? And the key takeaway, if you take away one thing from this talk, that's extensibility is number one. In any system that you're designing or in any software that you're writing, if it's not extensible, someone will throw it out at some point. And that goes back to the title of the talk today, right? Like if you're building something that you want developers to not throw away, like continue to sort of maintain, you have to make it extensible. And that's what WordPress did right. So there's this tweet which is like, you start editing like a WordPress theme, you're like, hey, I'll just make the buttons rounded because you know that fits my design scheme. And you're just like a PHP developer now and you're just writing WordPress for the next 10 years. So just to hit this topic home, right? What WordPress does is, for those of you who do not know what WordPress is, it gives you templates which you can start, you can go live in a day, but you can infinitely customize and infinitely adopt with plugins, custom code, and you can sort of entirely own what you're writing forever. Like there's no roadblock that, hey, this is not possible with PHP, this is not possible with WordPress. Now you have to like build your own system on like Node.js. Hey, performance might not be the best, but you can do whatever you want. And that's sort of what I want you to take away. Like extensibility is what sort of guarantees that this system that you're writing today will continue to exist in the future. And I'm going to take some examples from JavaScript. How many of you know JavaScript? Cool, so like half of you. And I'll try not to go into too much of like language syntax. I have some like pseudocode examples because this is like a polyglot sort of audience. But I resonate the most with JavaScript and TypeScript, and it's easiest for me to sort of convey ideas in those languages. So this is a library which is sort of like defining your UI for chat, and it's really straightforward. It's super popular, 12,000 stars on GitHub. That's like a massive field, and nothing to take away from this library. But this is what it looks like. So you have this component which is like a chat component, and to customize this, you have this entire tree of props, and just never ends. And imagine how difficult this is to maintain and to sort of write. So how this came to be, right? You made a chat component. Someone opened a GitHub issue. Hey, I want a prop which says like on quick reply this should happen. So they're like, cool, we'll add this. Then someone else opened an issue. They're like, oh, I want something when a user press this button. Like I want to do something else. Like, oh, cool, we'll add this. And we just ended up here. So this is great and this works. But this isn't truly extensible, right? Like you have to wait for the software developer or the library maintainer to add the feature that you want. This works, again, like nothing to take away from this library. This pattern probably works for them. And there's only so much you can do with like a chat component. but this isn't the best pattern. And I'm going to argue with another example. How many of you heard of Recharts? It's massively popular, 19,000 stars on GitHub. It's another library for React which lets you build charts. And they've taken a completely different way of doing this. It's again like defining UI and like defining things that happen in the UI. But what this does, it takes composition. So instead of saying that there's this component and you have to customize it, it divides it into pieces that you can recombine and recompose to describe your UI. So separation of concerns and sort of dividing these things into smaller pieces to be consumed by the end developer. So you can do things like, hey, I want the x-axis to look this specific way. I want the x-axis to exist, not exist. This just makes it really, really easy to like compose together. Does that make sense? Like, do you agree? This is a slightly better way of giving users tools to convey what they want. In the end, with UI at least, what you're trying to do is give users the flexibility to convey what that UI should look like, and then sort of they put this together. So that's sort of the idea of like, instead of having these props, you can just give pieces that people can combine together. Another example I want to give of...
question here, Ekaansh.
Yes.
The previous one, now this is not low code.
So let's not say this is low code, but this is sort of describing the idea of extensibility, which I'll come back to with low code.
Coming to this whole thing, so we have had all these lots of tools. There's Gnu plot, which has been there. So if you really look at Gnu plot, it takes, you can define a small script. I want a chart with this way, with these features, and you basically have to do. So again, if you're going to that level, you're essentially just picking up components and, I mean, I'm just pointing it out that this again is going. I agree with the fact that it's much more better than having one canned thing and no way of modifying it without taking inside it. Here at least you have the properties exposed and you can do what you want.
Correct.
Right? So
Yeah.
I agree. But then another way it may not really be the whole idea that we are trying to talk about.
With software, it's always like a balance, right? You have to decide like, hey, is this better? Is this like that? That's why we're writing code, right? Otherwise machines would have taken over and like, you would just describe a thing and like ChatGPT would spit it out. The whole reason why we're writing software is that we get to decide what makes sense, like what kind of abstractions make sense. And this isn't low code. What I'm trying to sort of describe right now is the overarching principles that we need to agree upon for writing good software. Once we've all agreed upon like this is how it should go forward, then we'll sort of see how we can adopt these into like low code, right? The problem with low code, as I tried to describe, is that we've sort of dumbed it down enough that we say that, hey, this is this component and that's all it does. What we're sort of, I'm trying to convey is that we write this component, but we give users the flexibility to extend this component in the future. And we'll come to it in a second. So moving to the next idea, it's like, if you're writing anything, you should be able to access the low-level code. And again, I'm going to take an example of React Native. There's this library called Skia, which is again super popular. It lets you draw graphics within React Native, but it's built with like a C++ engine. So with this, what happens is, it has a very like C++ type of imperative API where you describe in an imperative manner that, hey, take this and do this. But React itself is a declarative framework where you sort of define what you want, but you don't define the steps to achieve that. So what they do is they respect the platform standards, and instead of giving this snippet where you have to describe an imperative API, they give you again components which you can define in a declarative syntax, and they abstract this away of interacting with this in an imperative API. So all of this abstraction gets converted to imperative code, which gets executed by the Skia engine, which draws the graphics. So you're building this abstraction while referencing or while respecting the framework's bounds and framework's patterns. But what this also does, which I really, really like, is it doesn't lock you into this framework sort of declarative syntax, because this might be challenging. Like Sir said, that this might not encompass exactly what you want to do. You might have something that this sort of declarative syntax might not be able to be described in, right? So what it does is it gives you sort of like an escape hatch, where you can take this method and pass an imperative code. So most of your application will be nice and declarative, but when you want, you can access the lower level imperative API and sort of plug that in wherever you want. So it lets you escape out of the declarative pattern of the framework and come back to this imperative API to sort of not limit the user and allow them to sort of go back to, you know, the more complex way of doing things, but giving them ultimate flexibility.
Inline assembly.
That's exactly what I'm going to come to. that's literally my example. So there's some C code, right? You're writing like C code, but you can still like pass in some assembly instruction. And this is coming back to sort of the first slide where you are on this high level language, but you can drop down to assembly code, and that's exactly what Sir sort of predicted, that this is what we're trying to do. And the idea is that even with low code, you should be able to drop down to your library layer or your framework layer to sort of access that that pattern or that client or that library and be allowed to do whatever you want. So even though writing this assembly is not memory safe or it's not ideal or it's not easy to use, but you might be able to do some really cool things which is great, like very performant. For example, if you know like exactly what you're doing. Most people wouldn't use this, but this would make sure that the people who need to use this will not have to write the entire program again from scratch in assembly. Does that make sense? Like,
yeah, that sort of makes sense.
So now we'll sort of, I have a few more ideas, but we'll sort of take all of these concepts and bring them into like low code and how we're doing these things. Another example from React is, you have a declarative UI, but you are allowed to sort of write HTML and hook into a DOM node and pass your own things. And they tell you that, hey, this is probably not how you should be doing things. The taxonomy is great. They're like, this is not ideal. Dangerously set in your HTML exactly tells you that not your first option, but you might have to use this given some like constraint.
Oh, so that's the name of the.
That's an API, yes.
That's the name of the API.
Yes, yes. There's a React Native API. If you're writing like library, there's a scheduler API called "Do not touch this or you will be fired," and that's the exact API name. But you have to hook into it sometimes to make the scheduler like more performant and do cool things. Yeah, so I will talk about taxonomy as well. Taking another example of low-level code, I took a lot of React examples, but I want to drive this point home. That let's say you have some low code, just like pseudocode, like anyone should be able to understand this. Let's say you're instantiating some library or some low code tool, and it lets you do something really easily with like one simple method. But what it should also allow you to do is have access to the underlying SDK or underlying library, where you can take that SDK instance and do something that the low code wrapper does not let you do. And even though this might not just be like one line, this might be like a 100-page file, but you're not limited by the bounds of your abstraction. Hopefully that covers like extensibility and accessing low code. And this is my biggest gripe with sort of low code tools, right? Like the whole point, I gave this talk before, and one person that bought this point, which is exactly what I'm talking about, is usually it's looked upon like, hey, I want to spin up a POC in a week. Let's take this low code solution, spin it up, show it to your manager that, hey, we built this out. And now when this project is approved, you take your developer team and then you build this on like your scratch with the library, so that you make sure that you're not hitting into roadblocks and you're not constrained that next day the requirements change and you don't have to like do it completely right. If we're able to achieve this, I think we can make low code like the next step forward on the abstraction tree that I do.
The problem with that is that if your manager looks at the POC and says you did it in a week, so when you get the full project, you would have bid for a month's time and then I mean, this is a real challenge what marketing is going to sell.
And that's a people's challenge.
भाई हफ्ते भर में हो गया तो ठीक है, थोड़ा टेस्टिंग वेस्टिंग डाल देंगे, ठीक है, हो जाएगा, महीने भर के बाद करेंगे.
No, this is better. This is better. Never to sell the POC itself.
So I think next time I'll figure out like how to talk to managers and set expectations.
That's your takeout.
But yes, topic for another day. Just to take another example in a different language is, let's say we have some Swift code and you have an image and you want to apply a filter to it. Swift gives you this sort of like easy way of like, you can snap a sepia filter like 4 lines of code. This isn't technically low code again, but this is an abstraction. Like you don't have to take your RGB values, do matrix multiplication with another value and get a filter. It gives you like a standalone filter that you can just write in 4 code. I would argue this is low code, but you might not technically, like it's not conventional low code that it's marketed as. But this still lets you like access the underlying pixel data, which you can get a pointer to it, and then you can do your own computation. And it doesn't like limit you with only the given 7-10 filters that you have. This lets you like build your own filters and do matrix multiplication and do access the underlying pixel data, for example. I think I've talked enough about this, and hopefully like all of us agree upon this is good and this is important. Another like sort of the next way of getting into things that we should do is framework specific design, which I touched up a little bit about, like, writing declarative API in Skia, because that's the way developers of that framework consume your API. So you're making the developer experience better. And this is an example of Swift UI where you have an image component and you chain properties. So let's say I want to customize it or apply attributes to it. You do dot attribute, and if it takes a parameter, you pass it a parameter. Now if a Swift UI was writing this in React, they'd be very tempted to do something like this, where you have again attributes with some parameters, and this makes a lot of sense. But this would be very frustrating for a React developer because they're used to this. They already have a framework way of defining padding. Padding is a thing that exists within HTML and like React and everything. So if I do this and your library doesn't work, I'd be incredibly frustrated because now you're forcing me to learn your library when I already know how this framework should have this property. So you should respect the framework that you're building for, or respect the language that you're building for, and make sure that whatever you're building conforms to that API first, and then build features on top. Next thing I want to talk about is granularity. Taking example of this meetup, let's say to get here I have to like open the car door, get in the car, do some things, arrive here, meet cool people, go back, get in the car. There's a lot of things that are happening twice. There's a lot of things we can sort of abstract away, and we'd be very tempted to do something like do meetup stuff. Like that's this one single component. This is something you do every time. Like don't repeat yourself. Dry. Slap this in. Everything works. I would argue this is where we fall. This is the problem with low code. We're building wrong abstractions. We're trying to dumb it down for developers, and developers are not dumb. Like the whole problem with this is, isn't this a better abstraction? So you can combine things which make a lot of sense. So you can combine, get in car, start the engine, make sure everything's correct, travel to the meetup. So these things you're probably doing every time you're getting in the car. So it's all about forming the right abstractions and giving the right level of granularity in your APIs. So again, you're not repeating yourself because you make it more concise and this looks better. But this is not the best. Like we've understood this and we're getting closer to this with low code. But even this is not ideal. And how I'll argue that one level further down this granularity is that even if hit the perfect balance between making things more concise but giving enough freedom and giving enough flexibility, what if your user wants to do something between get in car and start engine, which you squashed into one method? And this is where again like a pattern which has existed for 20 years comes into the picture, and that's events. So in your library, where you're sort of abstracting away getting in the car and starting the engine, you can emit an event that hey, you're in the car now, and you can sort of the user can sort of hook into this event and do whatever they want. So I can do when I'm inside the car, check the mirror, right? So user in their user land in their application can access this event, pass in their own function which your library calls, and then they can just do whatever they want. Does that make sense? And this is such a powerful pattern. Like you can describe 100 events, and if the user does not want access to any of them, their code still remains 3 lines. But if they want to access all of them, they still have access to the whole entire tree. Like they don't have to throw away this 3-line syntax, go back to this 10-line syntax, and they still have ultimate flexibility of being able to hook things in between each step. And I love events, so hopefully that's obvious. So putting this together, this is where low code comes in, and this is where I'm sort of going to talk about some of my experience of building low code. So what you see on screen is like a UI kit for video calls. Again, this is a React-based thing because I like React, and I think it's a great way to write web apps. What you do is you have this component, you have some properties. Let's say I want to join a channel, I pass in that channel to the props. There's an identifier for the application, I pass that in. One line of code, you have your full-blown video calling built right into your website. This is arguably low code, right? Does everybody agree? Are we finally talking about low code?
Quick question here, so on that. So if I do this, I don't need any external provider like Teams or this or that or that.
So
Only in the browser I can talk to anybody.
yeah, so if you have a React application, all you have to do is sign up on like our website, get this identifier, put this in, and write this in your like React page. That's all you have to do.
Why do I need to sign up and get the identifier? I didn't explain it.
So I didn't want to go into like a lot of like company detail, but I can happily sort of talk about this for a minute. So we're a video SDK provider. I come from Agora, and the whole idea is that we manage the network for you, and network has costs, right? So instead of you spinning up your own like network like infrastructure, what we do is we abstract that away for you. So you go to Agora, you get an identifier like your app ID for any like SDK provider, right? You slap that in and you have to render this. So now you don't have to spin up your server which manages the video call. We do that for you. So this both abstracts away the backend side of it, the network system side of it, but this also abstracts away like building this grid, building this button, managing things when a user joins, what happens, all of those things. And this one line of code gives you this video call. So this is where low code comes in, and we're talking about how all of these software features and software patterns that we've discussed and agreed upon that are good, we've adopted and learned and utilized. Does this make sense?
Yes.
Cool. Taking the example of the first React Native gifted chat where they had like this massive props, we adopted some props as well. So like we can just pass in like, hey, I want this layout, so you can just pass in that prop, and the component is smart enough to understand what that means and render that for you. What we also do is we break this into pieces. Let's say you don't want to display controls. Taking the example of the first, the charts API that we have of like making things granular and breaking into components. This is something we do where you can take these components which pass in that data, give you access to like the grid, the controls, and you can like render them based on wherever you want. And we go one step further where we break the controls also into like finer pieces. So you can remove individual pieces, you can plug them together and like really own sort of what the UI looks like. Another thing that we do is we let you break out of the low-code UI kit layer and access the SDK. So there is no feature that you wouldn't be able to implement with this low-code tool that you would be able to implement with the SDK. Taking the example of, let's say, the SDK comes out with like this cool new feature called virtual backgrounds that's really popular right now, and let's say I haven't adopted this in the UI kit. So do you have to like throw out this entire UI kit and like go back to the SDK, build everything from scratch? No, right? Like that isn't what we're talking about. So you can, like this one line of code, you get access to the instance of the SDK, and then everything that the SDK does, you can do that here. So let's say if there's a method in the SDK called enable virtual background, you can call that, pass in some config, and it just works. So hopefully that ties in all of these concepts that we've talked about and how we can sort of enable that within a low-code paradigm. Taking the example of events, this is an example I really like, is what happens, we've made a lot of opinionated choices for users, right? In a video call application, you probably want to display things in a grid, or you probably want to display the things in a maximized layout where you pin one user and everyone else is like on the side or on the top, things like that. And that's opinions that we have made decisions for the end developer, which we mostly have seen that this is the common use case. You can break out of those, but if those are the things that you want to do, we make them easier for you. What I didn't want to make opinions for the developer is what happens when you click the end call button, because a lot of people might want to like close the tab, a lot of people might want to go back to the previous page, a lot of people might want to go back to a specific page in the website like, hey, your call has completed. A lot of people might want to write something to the database like, hey, this call lasted for these many minutes, these many people joined. There's so many things you might want to do when you press that button. So instead of saying that, like now you have to override this method, I just give you an event that, hey, end call button was clicked by the user, and you can describe exactly what happens. So when someone clicks the end call button, this sort of function that's a JavaScript way of writing functions, whatever you pass in within that function, I just execute it. Like I don't form any opinions on what happens. You tell me exactly what you want to happen, what the UI kit to do. And that's really powerful. And you can extend that sort of idea with more things, right? when a user joins the call, I automatically put them in the grid and I render their video. But you might want to do more things. You might want to write something to your backend, you might want to display a toast notification, and that's the example. I give you an event that, hey, a user joined, I give you access to that data, and now you can use that data to do whatever you want. So you have a third-party toast library, just pass that in and everything just works. So what we're trying to do is make this extensible enough that you don't have to throw this out and you're comfortable using low code and sort of understanding that this can be extended for a long time to come. And obviously we're not perfect, right? Like I'm sure there's some use cases that we have to make easier, or there's some use cases we have to like write a particular event for. Like there might be something really like niche that some user might want to do, like the browser resized, like I want to do something cool. And I'm sure there's events that we can add. But I think this is a very strong point, or strong starting point from the sort of understanding these are the requirements and these are the events we have, and we can quickly spin up like, here's another event. You want to do this? Here's another event. And so that's the idea. Coming back to taxonomy and again taking the example of React, this is a tweet from a year ago, but effects in React were sort of came out like 4 or 5 years ago. And we still haven't been able to like agree upon what they should be called. It's a 5-year-old API and we're still arguing like, hey, it should be probably called like use synchronize instead. So if we can argue about an API for like 5 years, when you're writing that API, you can probably spend 5 minutes to make sure that this taxonomy makes sense, and we don't have to fight for like the next 5 years if something becomes popular. Coming back to the dangerously set in HTML, it tells you exactly what it does. Like, do not use this. But if you have to, it's okay, you might want to. This is an example of taking it directly from the Swift docs. They're great docs, and you should take a look if you're writing documentation. Like Apple does a fantastic job of writing docs. I just want to jump to this example because we're like sort of short on time and I want to cover like a few more things. Taking the example of array.remove, when I say remove 0, am I removing the 0th element? Or am I finding an element called 0 in my array and removing that? It's not immediately obvious. Like if you know the syntax or the library, you understand what this does. But as someone who doesn't speak Swift, it's not intuitive. But if you call it remove at, there's no confusion. Remove at 0, like yes, that's exactly what I'm doing. But this is not to say that you should like write like a 6-word API, because we don't like to write things. So you can do something like, if a view is a collection of elements, it's really obvious that you're removing an element. So remove the cancel button element is concise enough. But I would say, if in doubt, like be as explicit as you can, be as expressive as you can. We have like auto-completed stuff now, so like you're not writing like a lot of function methods by yourself anyway. There's Copilot writing like half of your code, so it's probably fine. But yeah, like figure out what the API is doing exactly and sort of make it really obvious that you can avoid a lot of errors when this happens, when like a confusion happens. Another thing that you need to sort of understand to ensure the success of a low-code tool is the documentation. And I couldn't figure out a good way to convince people to write documentation, so I just like look at this example where you write some code and you're like, who wrote this piece of trash? And you do like a git blame and you see like, oh, it's just me who wrote this like a month ago and I just forgot like this unmaintainable piece of code that exists, and I have to like backtrack my steps on why I wrote this and why this works. And it's just a very humbling experience. Like we're all writing bad code, but if I just left a comment on how this works, I would just avoid like an hour of figuring out what this is. And if I can't figure this out after like 2 weeks, good luck like a new hire figuring out what this does when they like read the code base for the first time. So yeah, write documentation. I love writing inline documentation. There's a cool code which like we has met the enemy and it is us. So the biggest problem with writing software is usually you yourself. And the sooner we accept it, like the better we can write the documentation. There's another like comic which says that if your documentation needs a documentation to understand how to read the documentation, then you're probably doing something wrong. And you should probably write it like, make it really obvious what this is and like try to explain it in like simple terms. We all, like as developers, want to sound smart, and that's why I put like example of like C++ and assembly. I don't write assembly, I just like talk about assembly to look cool. But like, yeah, you should, when you're writing documentation, don't look cool, write it like a 10-year-old is sort of trying to understand what this is. And we've seen like 12-year-old developers on GitHub doing cool things. So I think that should be like the minimum bar. Like someone new to this, who doesn't know how this language works, should still understand what I'm trying to do. Talking about errors, there's this tweet I came across last year when I was working on these slides is, as developers, we sort of want to solve problems. And this is from Evan Yu, who built Vue.js. And there's a paradigm in JavaScript which is called monkey patching. So you have a library which doesn't work. You go into the library, build a patch, push it to like a local repository, and like ingest that patch into your program. There's like a whole term for this because this is so often enough that we have to like override and customize a library that we built a term for this. And I completely resonate with the idea that you get extra frustrated if there's no way to fix the problem that a library introduces. Like I can't wait for you to like, you know, open a GitHub issue and like wait for you to fix this. I just want to be able to have a tool or have a way of being powered enough that I'm allowed to fix this. And developers are willing to solve problems. So if you're building a low-code tool, or if you're building software in general, like you should figure out a way that, you know, people can, you know, work around those errors and like fix them for you. Even that's like the extent developers are willing to go. But that's not to say that that's the only way. If you have descriptive error messages, error codes, error descriptions, and write good APIs and good patterns to show that this function can error, the consumers of your API or of your library or of your low-code tool will be able to sort of adopt this and manage when your software breaks. And I want to take an example of JavaScript again, or like any paradigm programming language which does like a try-catch block. Golang does this like in an extreme way, but I think JS does it in a better way where you have a method which is like, you know, this method can error, and the right way to do this is do a try, catch the error, handle the error. But I've just seen people do this, and you just see like the whole page go blank because you get a promise unresolved on JavaScript, and I'm sure this would like crash your app in Rust or whatever because you didn't handle the other case of when this network call fails or your TCP packet doesn't come back to you, for example. So another pattern of writing the same thing is you tell the user that this thing can error, and this gives you a data variable and an error variable. And with TypeScript, what you can do is, if you haven't checked that this data is null, your data would be of the shape undefined or the value. So it will always tell you that, hey, this might be undefined and you can't use this right now. So you can use sort of like a linter, or you can use syntax from your language to enforce good patterns. And now you don't have to write the try-catch block. You're still writing that let something equal something, but you're sort of forced to check if that error exists or if that error does not exist. Only then you can access this data. And there's so many ways of like doing this. I just want to take this pattern which I really like to sort of describe what I'm trying to say. Another example is using enum. So if you're doing string compare in like C++, you would do something like this, but it wouldn't match because W is capital in one case, and this causes problems. You can use like an enum, and then you can just do like today is of this type, and if you do like a small W, it will give you an error. So instead of waiting for errors at runtime, it's better to have errors during like compile time, so that you can make sure that your things work when the user is using them. Developers can work with this. Users just complain and open Jira tickets, which is annoying. So we have another 15 minutes, so we'll talk about this as well. You can use getters, like you can do things like this. I'm just going to gloss over this, but the idea is that if you describe a thing as a property on an object, then your user might, like, again, taking the example of users being annoying, they can override this to say that, hey, I want to change the time to this, which will cause problems. But if you describe the API in a way that this is a function which returns time, now your user understands that, hey, this gives me the time, this isn't a writable where I can write and change the time. So again, this code doesn't make sense anymore because get time shouldn't take a value, it just makes sense. And I'll leave these slides on like Twitter or somewhere or GitHub, like you can take a look to sort of understand what this means, and I just want to save time for questions later. Last thing I want to talk about is this tweet from Best Boss. He's on the Chrome team, developer advocate, works with PHP. He's like, JavaScript is great until you see the PHP guys with Lambos. So, I mean, low-code has money in it, WordPress developers get paid a lot more than JavaScript developers. So maybe if that's what incentivizes you to write, like start writing software, this tweet will sort of lead you into the low-code direction. And I sort of want to leave you with that idea. Thanks for your time. The whole idea of talking about this is build cool things to inspire cooler things, and hopefully I was able to sort of talk about like building like a core API to sort of inspire you to building and experimenting with low code. That's been it. I'm Ekaansh. If you want to reach out, like Twitter is the best place. Happy to answer questions, and we have exactly 15 minutes to sort of go out and answer questions. We want to pass on the mic.
We have one more mic.
Yes, thanks so much. Turn on. Yes.
May I know like what you are using for these pictures?
It's called Slider. It's a Vue.js based program. So what it does is you write Markdown and like HTML, and it converts it into like a website which you can like click next and does like cool animations. And it's like a declarative way of building PowerPoint. And I really enjoy working with this because you can really express what you're trying to do. And hopefully it was like a good experience of like, showing presentation while not being like, oh, this is great. I don't like PowerPoint.
No, when we are talking about low code, we should be using PowerPoint.
Yeah, so it's a good example of like writing Markdown, which is like a low code way to express this. I want to use this instead of like.
No. While giving demo for low code, we should follow low code first.
It's sort of low code, right? I didn't code out the website. I just wrote Markdown. So it's like hashtag heading, and it converts it into like HTML. So I didn't like write, and I can quickly show you what that looks like, right? So again, arguable, right? Like low code isn't very descriptive. So I didn't build a chart. I just said that flowchart CPU assembly, and it just does it for me. It just builds out like this massive div tree of that diagram that you saw. And if you go down further, you can see like, okay, those are examples, but hopefully, yeah. So you see, this is like syntax and just formats everything in like technically low code.
Maybe I should ask this question when they say no code.
You will do a PowerPoint.
Yes, when I do no code, when I talk about no code, I use PowerPoint. But I think we're not there in developer experience right now. You want a chocolate?
See, in my presentation, I didn't use slides. You can call that no code.
Hi, Ekaansh, Palash here. Hi, Ekaansh, Palash here. So, fantastic presentation.
Thank you so much.
I wanted, mine is not specifically a question. It was very interesting when you said something like, throw the error at compile time, not at runtime, because I come from a mainly Java background. So, that's like a Java developer. That's like a problem 20 years old. And we hate that. So, yeah, it was great to know that. So, I think the main, because I have worked in a lot of proprietary software where people try to develop tools and low code and no code, it's been an ongoing struggle. The challenge here is, I think, not in the usage but in designing, which you cover.
100%.
So, and everyone thinks they are a good designer till you start designing and you have a deadline by Friday and you want to go out on weekend. So then that's when you get this issue. So do you have any checklist, since you guys have already designed the UI kit, which you can share and which we can kind of look through to go through your experiences where you pitfall, somewhere you can share? That's my question.
I can try to work on that. Like that's not something we have. It's just like an ongoing team effort where we discuss patterns and ideas that this is my user who's complaining about this. How do we solve this with low code? So that's usually how we come. Like all of what you've seen is us constantly making bad abstractions learning from our users and then improving those abstractions, right? So I don't think we're all like 100% way there. What I talked about is sort of, concise way of putting together ideas that we've learned over the 2 years that we've been doing this. And maybe I can put this presentation into like a checklist. But yeah, I don't have something for you right now, but
Yeah, I mean, that would be the main value that as a developer I would be looking for. This is priceless. We've actually worked on it for 2 years. So yeah, please share.
I'll put it on like GitHub and like maybe add something to this presentation and see how that goes. Thank you.
Talk about why is it being so popular? Why is it being so popular? Why is Gartner saying that the last 65% of market?
A lot of it is marketing. I'll be very honest with you. Like I'm not trying to here to shill about logo. Like I'm not like a I'm not predominant. Like even if given the choice, I might not use low code myself. So I wouldn't shill that hey, low code is the future and this is exactly it. But I think we slowly realized that we were building bad abstractions, right? And that's sort of the whole idea that the problem was you take this tool which is like, hey, we're solving all your problems and you can get started in a day and you write these 4 lines of code and everything just works. And like a month later we realized that, hey, we hit a roadblock and now we just want to do everything from scratch and we've wasted this month of like, working around this tool and working around these limitations. As the ecosystem evolves, like I think the first language like he talked about, Java had problems, right? We still use it, but we've learned from Java and built better languages. Like Rust sort of lets you do, a lot of things, going again lower level from Java, but making the syntax nice enough to sort of like the whole idea is we're constantly learning, and low-code tools are maturing to the stage where they might become the default way to write software. So that's the idea. Like maybe 1 year, 2 years, 3 years, we get to a point where low-code evolves to a point where we don't need to, write like we don't write assembly anymore. We wouldn't need to write, high level languages and things like that. Does that make sense?
But what you are saying, Polyglot is going to do the same thing. And what you are saying, like if you include the chatbot, then it's going to do the same part of it.
It's just going to reduce the developer effort of writing software so that you can focus on other things around that software.
And if you take that all the cloud infrastructures, you just does not need to do it. You just put that and it do the same thing like ETL Java, like AWS Blue or Blue.
Exactly. Terraform is like you're describing this thing and just does it for you.
Yeah. Then most of the components are newly developed components. They are moving toward the same side.
That's the idea. Yes.
Sorry, challenge that you are asking.
Okay.
What Gartner is saying, I think, is not about the developers the way I look at them today. See, pretty much everyone in this room is pretty much BTech, MTech, MS, MCA, right? But if you look at software development is getting commoditized.
Okay.
In 1920s or so when Ford was developed, it was for niche people. But today you have 100 rupees, you can take an Uber and have the luxury of going in a car from point A to point B. 15-20 years ago, you needed a specialized handy cam to record a video. Today, everyone can
has a camera in the pocket.
So that's precisely the idea. So the definition of software developers, we are looking at it using today's benchmark of who the software developers are, and that is how we are trying to find the gaps, and precisely where you say that software developers of today, you personally will not like to use. So I think the onus is probably on the software developers of today to make those abstractions right.
Make the correct abstractions.
But this is not precisely for high-tech skilled people to be able to develop software. That definition of who is going to write the software is going to change over the period of next 5 to 6 years.
That's possibly.
Everyone can make a video, right?
I agree with you. I think.
And that is where the 65% will come.
Yeah, like I agree with the example of assembly again, because like right now there might be like couple thousand people who still write assembly, and that skill will continue to exist, right? It's not going anywhere. We still might want to write firmware, we still might want to write motherboard BIOSes, which again are inherently written in like a very low level, like you're probably writing assembly or binaries or something like that. So it will continue to stay, like traditional programming is not going anywhere, but as more developers come and write software and the bar to enter into software development becomes lower, things like these will sort of help democratize that effort. Yes, 100%, I agree.
So the Gartner report that you mentioned, does it also mention what tools are there?
I just picked it as a headline topic. So that
Go to OpenAI. Go to OpenAI. I think you'll find a full SDK about the low-code.
Yeah, the entire low-code industry, like, they are talking about citizen development
Yeah, that's the transition we're seeing, yes.
So where does this platform like APN, like IPN, BPN, so which also helps you develop applications quickly. So where does that fall? I mean, that is actually the true low-code and no-code platform. So
I think this is not like my research into this topic. This is just my opinion on what I've seen. Is that we haven't solved for this one tool, one low-code tool which can do everything. I think we are still like a couple years ahead of reaching there. But what I think right now, maybe in the next year, what we are solving for is picking a niche use case like video calls and building a tool which can solve that with low-code. Right? So I think we're getting there. Like we can pick specific tools for niche use cases that can be solved with low-code, but not like a general-purpose tool which can solve for everything. With programming, you have a general-purpose language which does everything. Right? You can write anything in JavaScript. There's a code which says like, if something can be written in JS, will be written in JS. I don't think we've reached there. Like, I'm sure the tools that you're talking about is more general purpose, but I think we still need to learn better abstractions to be able to solve for that.
Yeah, because the Carter report primarily targets to those platforms.
Correct. But I think that's a little inflated. Even in my opinion, like my whole idea is to sell local, but I also wanted to tell you like that's probably not where we are. Like we still have a lot to learn, we still have a lot to discover before we reach that.
So I don't think that is going to happen. It's akin to writing a software that will do everything. You will never have a platform which will have like no code for everything. I think that is just imaginary. That is
maybe next 10 years we never know. we thought Moore's law will stay forever. Like it's almost done for.
Yes, sir. There are platforms where you can drag and drop.
Programmerless, that is
You can drag and drop a text box or a paragraph.
that cannot be everything. It's specialized for specific purposes. You can
I think you almost asked my question. So you have used React to build a no-code tool, right? So what are the other no-code tools which you are familiar with?
The UI kits that I talked about, almost the exact same syntax you will see in Swift, you will see in Android Kotlin, you will see in Flutter, you will see in React, you will see in React Native, and we're also working on a Unity thing coming in the future, so like C#, something like that. So we're trying to do and follow these programming practices and these patterns across the entire stack. So it's not limited to just React. I am a React developer, so that's the best I can communicate in. But these same things that you see are available across these 5 platforms.
Sure. I think lastly, low code could mean different things to different people.
100%. It's a spectrum of what is you can't define.
Like ServiceNow is a low code platform. A lot of people say, Power Apps is a no code, but it could be low code, right?
Exactly. Like arguably WordPress is low code, right? You just like plug in something and write a few lines of code and it works. But I think it's a bit of a marketing term to sort of make people transition to these systems. But I think there's value in sort of making things more concise by building abstractions. So that's how I like to define it. Like what is low code is just another way of writing like cleaner abstractions.
Thank you.
I have one question. Like I have used this Arora platform, so just wanted to know, is there only this video SDK available or are there any other things?
So we do video SDKs, we do live streaming, we do chat, we do cloud recording. There's like a couple softwares related to like the real-time engagement space. We have multiple SDKs for these things.
And one more thing, like I work on this low-code platform, OutSystems, you might have heard this for the web development and application development basically. So how to add Arora into this? Because we can import this in the React. But OutSystems is basically the on the cloud basically. So how to import this and all? So that we need the extensions. So do you have all these extensions for the other low-code platforms?
I think you can reach out to me on Twitter and I can figure it out because I'm not like very familiar with OutSystems. So I can take a look and we can sort of work together to figure out like what's the best way to either enable that for you or take that as a feedback and like build that out for you.
More like an API call that can
what I mostly talked about is predominantly front end, so there's not a lot of API that you're managing, but we can figure out. I'm sure there's a way to like enable that.
So do you have something like a StreamYard replacement where you can live stream on various platforms?
Yeah, that's essentially what you can use it for as well. StreamYard is predominantly RTMP based. We also do like an SFU based. So with RTMP you have like a 1 or 2 second gap between your stream and the consumer receiving that stream. With the SFU based protocols, you have that gap reduced to like 200 milliseconds. So it's truly interactive.
What is the SAQ?
Low-code tags.
Yes, ma'am.
Then you write it low-code.
understanding of
100%.
what you want actually.
Correct.
So to get the knowledge of assembly, what we are saying, prior to this when you are downloading any jQuery, so you need to know that what is the jQuery does it,
Yeah.
are the parameters we have to follow it. Is that same thing we need to do for the low code as well?
Partly yes, partly no. Partly yes, as in you need to understand, like when you break it into components, you need to understand at least what the component does. We try to make it very expressive, that mute video button.
Correct.
That probably makes sense. Like if you pull that up, you will understand what that means. But you need to understand how to put these together. For example, there's a context which gives data to these components, so that needs to be wrapped on top of these components. So there is still some learning curve. You'll have to understand how this tool works, and there is some like learning curve, but it's widely reduced from understanding jQuery, for example. So we're trying to make it easier, make it simpler, but definitely there will be some time of like understanding how this tool operates.
So what is the prerequisites of to know the low code?
It depends on the low-code tool itself. In our example, you will need to understand how React works.
Okay.
So if you understand how React works, you could spend like half an hour looking through the docs and you will understand how our tool works.
Agora is open source or is it proprietary?
The UI kit is open source, but most of the key prospect of using Agora is that we manage the infrastructure for you. So all of the infrastructure is like a black box, that's proprietary. But interacting with that, like this entire thing that we built is open source, so that you can learn from it and like build like your own abstractions and things like that. Yeah.
So you told you are maintaining the system. For example, I use your video streaming. Do you store the data what the API I am using? My people will be using lot of chats. Okay. Do you store all this data? Because you are giving the service, right?
Can you describe what this data means? Do you mean like the video call itself?
Yes, video call itself.
So by default, we don't store any of your data.
Okay.
But we have services like cloud recording, which enable you to hook into this life cycle, capture the stream, and store it on like your S3 bucket.
Okay.
So we can like spit out that entire session and give it to you on like a S3 base.
So when you give a service, it is like if I want to store it, I can store it.
Yeah, you can store it, but by default,
no, I'm not. My question is not that. My question is. Without my this one, you are giving the API. You have all the facility to store the data. You have all the permissions to store the data. So whether you do that one?
No, we don't store any data. And we're also like HIPAA compliant and GDPR compliant. So that essentially means that we've audited our systems to make sure that none of the user data is stored on our systems.
Okay.
And we have both those certifications on the website, so you can like take a look.
Okay.
So by default, none of the data is stored.
So which language you have used to written your Agora UI kit?
It's all built with like React and TypeScript.
So we have been using we have been doing the plug and play with in the back end, like with the third-party jars, and in the front end, like in the Angular third-party like npm dependencies. Like how different the low code is? Like is it same?
It's the same, but to a greater extent. So the abstraction that Express gives you on top of Node.js is one level. What I'm saying is with low code, it's taking that to a whole different level, to another next step of it. So this abstraction will be, make it more concise, make it easier, make it simpler, but the whole idea is the same.
It's kind of API, like
making the API like more convenient to use, making the API like shorter, taking more user opinions and bundling them as part of the API.
Could you tell us more about your component architecture? Means you are opening the SDK in your component, that is it, from very high level, but you are interacting to the system, right, for the video. How do you do that actually? Could you use your any own layer of abstraction or something else?
Cool. I think we're running out of time, so I think this is the last question. Okay, last question. But the idea is to sort of describe how this works is there's multiple layers to it, right? There's your actual underlying video layer, which is part of the browser's API. So this is not something that we govern, it's something that Chrome, like all of these W3C maintains. On top of that, we have our SDK, which sort of gives you an abstraction so you don't have to work with media stream tracks. That's how it works on HTML.
It's in C++?
Sorry?
It's in C++?
Usually media stream track is implemented by the browser, which is C++, yes. But you interact with this in JS land. So it is a Java. So it's C++, then JavaScript, then our SDK, then our UI kit. So it's like multiple layers of abstraction, and you can break down to as many, like as lower layer as you want to go. So you can even go down to the CJS, like the JavaScript layer of like actually taking this video buffer data and manipulating it, like making your own filter. So what we're trying to do is make it extensible so you can go down as many layers as you want. Yes, sir, last question.
And since the low code is generalized, I mean it's not for one customer or specific use case, will there be any performance compromise from that standpoint?
I'm very tempted to say no, because if you follow the best practices and you write abstractions in a way where performance, reliability, speed, all of these things are a key importance, then you're essentially writing application code, right? Code that you would have written, I'm writing it by myself and giving it to you. So if you make sure that these abstractions are followed correctly, I would argue that my UI kit might perform better because I know exactly how the SDK works, right? You might make mistakes. I'm not saying you in particular, but I'm saying like an end customer, we've seen them make like a lot of mistakes and we're like, this can be improved, and we're sort of writing a lot of best case scenarios, like best use cases, like best practices of our SDK and imbibing them in the UI kit. So ideally there shouldn't be performance deficits if it's written correctly, like with any software. Cool, thank you so much everyone.
Thanks.
Thanks for your time and sharing all this. Thank you so much.